Hello all, I Aditya Chaudhary welcome you to the second episode of Arduino with MATLAB. This webinar is organized by MATLAB Helper in association with Eravat Foundation. In our previous webinar, we have already covered basic topics and use of Arduino with MATLAB. If you haven't watched the first part of Arduino with MATLAB, visit mlhp.link/live Arduino to understand the basics along with the initialization of Arduino Uno with MATLAB. In this webinar, we will be covering yet another topic and projects using MATLAB and Simulink. If you do not have the hardware, you can buy the entire kit from mlhp.link/Arduino kit. All the links are mentioned in the description box below. And if you are watching this video from our blog post, you can directly click on the button to buy the kit. I'll be also revealing the Arduino with MATLAB contest in this webinar, through which you can get your Arduino kit for free. Yes, you heard it right, you will be getting it for free. We will be discussing about the contest in detail during the webinar. So stay tuned, keep watching and ask as many questions and difficulties as you can. You can comment down on the video on YouTube, or if you're watching it on our website page, you can comment there as well. I'll get back to each of your queries during and after this webinar. If you wish to suggest something or give app feedback for the webinar, write down to us at team@matlabhelper.com. So let us start learning.
Okay, so in this webinar, we are going to cover a lot of topics, and first of all, we'll be revising the basic concepts of Arduino, which we have already covered in our previous webinar. So to do that, let us watch this small explanation video when I'll be telling you what exactly we have already covered in our first webinar. So if you want to watch the webinar, the link is given in the description box. In the previous webinar, we have already covered how to install the add-ons which are necessary, or the support packages which are necessary for using Arduino with MATLAB. We also showed how to set up your Arduino, how to install your Arduino and check if the connection is proper, or how to set the COM ports. Later on, we have covered how to use the basic blink program to blink the onboard LED, which is at pin number 13. Then we did it for an external LED using a breadboard. We also saw a few functions wherein you can change the values of the blink delays. Later on, we saw how to connect everything to your Arduino board. We also saw how to connect the servo motor to Arduino, and in the last phase we saw how to use the potentiometer to control the brightness of the LED. So as you can see, everything was in a structured manner, and we are going to do the same for this webinar as well. So this webinar and the next webinar, which will be coming up with in the next month, is something which would be related to each other. So in this webinar, we would be, we have already revised the basic concepts, and later on we'll be controlling the servo motor using Simulink. So the servo motor connections were already discussed. You can see it on the screen. You have to connect your servo motor accordingly. So we'll be controlling the servo motor using Simulink rather than the programming. So that's just a minute of task. For that, you have to visit the documentation of MathWorks, which is on servo control. So you need to install this Simulink support package for Arduino hardware, which I have already did in the first webinar, so I'm not going to do it again. And to check with the servo control, they have directly given it, like you just have to try it in MATLAB. So simply click on try it in MATLAB and copy this code. So this is the way you can make use of MathWorks documentation in your regular projects as well. Okay, so I'll just copy this part of the code and paste it in our MATLAB window, like in the command window, and hit enter. So this should open the example Arduino slash server control example into the Simulink. So it shows my MATLAB is busy, so I'll have to wait for a few more seconds to get it open. Meanwhile, I've already connected the servo motor to my Arduino. So as you can see over here, the connections on my screen describes the way you have to connect your servo motor to Arduino. And we have already covered how to program servo motor using Arduino, using MATLAB. So you might have watched the first episode, and in that I've mentioned the connections as well. So if you have any queries, you can scroll back to the first episode and check if the connections are proper or not. It might take some more time to open. Meanwhile, if you guys have any queries regarding anything, you can comment down in the section below. And if you're watching this webinar from our website page, do comment on the website itself so that our team can get back to you as soon as possible. Okay, so this is the server controls web model, which is which is the example of Arduino. And to run this model, as it says, to run this model on hardware on Simulink Editor toolbar, click the Deploy to Hardware button. The model runs as a standalone application independently of Simulink. So that's the speciality when you program using Simulink, or when you use the blocks, you can deploy it to the hardware directly rather than writing a program for it. So let us quickly start deploying it to the hardware. Let's start the process, but before that, let me show you guys the um, connections which I have made. Let me revise the connections with you. So there are three wires coming out of this servo motor here, and the orange wire is connected at pin number 4 of Arduino. The red wire is connected to the 5-volt supply of Arduino, and the black wire or the brown wire is connected at the ground of the Arduino. So you can see I have not connected the Arduino to the computer yet, but when I connect it to the computer, it gets powered on. So now we'll be coming back to our screen and we'll be deploying it in on our Arduino. And to do that, um, so here's the button deploy to hardware. So we're going to directly click on this button over here, but maybe before that we need to change some settings. So I'm just waiting for the drop down option which says deploy to hardware button. So guys, we also have this contest which is coming up, and I'll be discussing about the contest in this webinar itself. So stay tuned, watch the webinar till the end and get your Arduino kit for free from MATLAB Helper. But for that, you need to enroll in the contest and you have to share your idea. I'll be telling you more about the context in this webinar itself. So you can see the block is getting compiled, compiling completed, and there were a lot of processes which are going through. So I'm just waiting for the final output. So the pin number for the Arduino, like the servo motor is connected to Arduino at pin number 4. So that's what I have set over here. The compiling part of Simulink, takes a bit of time, but yeah, that's more easy rather than coding each and everything, coding for each and every block. And the compiling takes place only once. Later on, you just have to drop some few more blocks. You can add it, and everything is done so quickly. So that's the magic of Simulink as compared to MATLAB, wherein you have to write the program, from the scratch, and here you have the blocks instead. So you can see the model is getting built, and this would be a standalone model rather than it communicating through the serial communication protocol with MATLAB. So we are building the model, and that would be a standalone model on the servo motor. So it has given me some error that the procedure of model aborted due to an error. The COM port could not be automatically set. So for your Mega 2560, and we are using the Arduino Uno board, so we need to set these parameters using the tools over here. So I'll click on tools, run on target hardware, and I'll go to options, and in that options we'll be having an option to set the COM port manually, as well as set the board which we are using manually. So let the hardware implementation. So you can see the no board is actually selected in this. So what I'll do is I'll just click on the drop box over here, and that should show me a list of Arduino boards. Okay, so it's updating hardware board parameters. So that's what happens when you go for it like for the first time. So once you are done with it, it's very simple, it's very easy, and it won't take a lot of time. So in the hardware board, I'll be selecting Arduino Uno. So initializing hardware board parameter values, please wait. uh, Once it's done, you can click on this target hardware resources, and in that you need to select the COM port. So you just go to serial port properties. It should be read at 9600 baud rate. That should be the baud rate. Host port connection. So set host COM port automatically. Instead, you go click on manually, and COM port over here. To check the COM port, what you can do is you can go back to Arduino instead of going back to the device manager and checking the COM port. So you just click, you just type a equals to Arduino with empty parenthesis and hit enter. So this should give you the COM port as the answer. So I'm just waiting for the answer. So in this part you can see it will automatically detect the Arduino, and okay, Arduino cannot be detected. Make sure original hardware is properly plugged in, otherwise please specify both port and both port type. So what I'll do is I'll disconnect my Arduino and connect it again, and then I'll type the same command so that the computer reads the Arduino well. And even if it does not read it now, then we'll have to go with the original method, which is the device manager method. So what I'll do is as I know that the Arduino is connected at COM2, and that's an Arduino Uno, so I'll just specify Arduino Uno and COM port 2. And now let's see if it reads the Arduino or not, if it can detect the Arduino. So I've already covered this part, like the troubleshooting part, in our webinar 1, and I'm hopeful that you guys are um, it still says unable to find the Arduino hardware at COM2. So the last step of debugging is opening the device management.msc using your run if you're on Windows, and then you'll have to check if the Arduino is connected properly or not. To do that, okay, so in this part you can go for the ports over here, USB serial. So that's COM3. Now let's specify COM3 instead of COM2 and hit enter. Now it should work. So this is how you will have to debug the Arduino and set up the Arduino, which I have already covered in the first session, but to show you guys how exactly the errors are, I'm just repeating the steps in this session as well. So you can see updating server code on the board Uno. So if you're connecting the Arduino Uno board for the first time to the computer, you will find this coming up like updating the server code on board Uno COM3. So let this happen, but we'll be going to the Simulink part, wherein in the configuration part we'll be setting the COM port to 3, and I'll click on apply. Okay, since the MATLAB is already working with the Arduino, it's updating the server code in the command window. So I'll just wait for a few more seconds so that both my tasks are getting completed at the same time. So once the server code is being uploaded, yeah, it asked me for the security, so I'll just click on allow for now. That is what you guys also might be required, because many of times firewall stops updating such things, the external hardware as well. So once you're done with updating the server code, I'll simply apply this configuration parameters in Simulink. Meanwhile, if you guys have any queries, or if you want to ask anything, you can just comment down in the section below, so that I would also be able to reply or work accordingly. And if you guys have any suggestion for our next webinar, do comment that as well, so we'll be including those things in our next webinar. But we are trying to go very slow this time. We are building each and everything from the scratch, so that you guys can acquire the hardware. If you guys haven't acquired the hardware, then visit the mlhp.link/arduino kit link, which is given in the description box. You can get the hardware kit for yourself, and if you want it for free, if you want it to be sponsored by MATLAB helper, I'll be sharing you an idea of the contest which I talked earlier as well. So you can take part in that contest and win the Arduino kit for free. So it's taking a bit of time. Okay, so the updating on servo is done, and I'm clicking apply over here. So I've already applied these settings, and I'll click on OK. So you can find the COM port, Uno, available pins and everything, all the details over here. Now coming back to our servo control model again, and I'll click on deploy to hardware. So this is the very important step in Arduino, when you have to configure the tools, configure the hardware parameters, so that your code works. Most of the people run it on the target as instructed over here. They deploy it to the hardware, but they do not know how to change the configurations, which is very important in order to build the model, run it on the target hardware. So I'll just connect the servo motor again, which I had disconnected earlier. I'm connecting it at pin number 4. It is already powered up by connecting the other two wires at pin number like the 5-volt pin and the ground pin of the Arduino. So once the model has been built, it will be deployed to the Arduino. So I'll be waiting for a few more seconds so that the Simulink will deploy it on the Arduino itself. Okay, so this was the error because anyone can guess, anyone can comment down. This was the error because we have already using the Arduino from MATLAB. So I'll have to clear all the variables which are in the workspace. So you have to clean up the Arduino every time you use it. So I'll have to clean it up again, and then once it's done, I'll be running the Simulink model again. So I'm just waiting for it to clear all this variable, and once it clears all these variables, uh, yeah, as you can see now it's been cleared, so I'll deploy it on the hardware again for the last time. So when you deploy it on the hardware, like this is the very easiest thing which you can do using MATLAB, or rather using Simulink. So it again starts initializing, it will build the model and it will deploy it on the hardware. So I'm trying to go very slow, and I'm trying to cover all the errors which you guys can um, encounter with, and I'm also telling you the solution for each and every error so that you guys don't make the same mistake. I'm going very slow with this part because using Simulink and MATLAB together for hardware is a bit difficult, and that's where most of you guys would be requiring the help. So I'm trying to cover all the errors in this webinar rather than covering more topics, so that you guys, if you face any of these errors, you would be capable of uh, debugging them, not only for the servo motor or the Arduino, but you can debug it for all the Arduino, like all the hardwares as well. So it's building again, and this time it should deploy. Okay, so in the video, as you can see, the servo has started working, and it's changing its direction from left to right as the steps were given to it, and this thing is running on the hardware. Nothing is being controlled using Simulink or using MATLAB. So let me show you the blocks. So this is the desired shaft angle, which is a pulse basically. So you can see the vector output is the angle goes from 0 to 180 with the steps of 1, with the sample time as zero point 0.1 second. So let's change it to 0.1 second. I'll click on apply, click on OK, and I'll deploy it to the hardware. So once I deploy it on hardware, the same procedure starts. It initializes, it builds the model, and it will deploy it on the hardware. So I'm waiting for it to be deployed on the hardware. Okay, so now it's being deployed on the hardware. Now you can see it's moving very slowly. So I've changed the sample time to 0.1 second rather than 0.01 second. So it's going very slow. It's changing its angle from 0 to 180 degree with the samples, like decreasing each angle 1 degree at the time, and it's going very slow as the sample rate is zero point 0.1 seconds now. So in the similar fashion, you guys can play around with these two blocks and check out the applications of servo control, and you can ideate this thing into some kind of a project And if you have any project or if you have any difficulty using it in your project, you can contact us at team@matlabhelper.com and we'd be glad to assist you. So in the next part, we'll be using the ultrasonic sensor to measure the distance. So stay on with me, and meanwhile I'll be telling you about the contest.
Here is the most awaited part of this webinar where I'll be discussing about the Arduino with MATLAB contest. To make the webinars more engaging, we want you guys to participate in this contest. The contest is very easy. If you have any idea that you can implement using Arduino and MATLAB or Simulink, then submit your ideas on our webpage. If our team shortlists your idea, then you along with your idea will be featured in our next Arduino with MATLAB webinar. It's not that, we also have giveaways for lucky participants. You can earn your Arduino kit for free. All the participants shall be entitled with a certificate of participation, and one lucky participant will be given the Arduino with MATLAB kit for free. So what are you guys waiting for? Grab this opportunity and get Arduino with MATLAB kit delivered at your house.
Okay, so in this part, what we will be doing is we'll be connecting the Arduino. We'll be connecting the ultrasonic sensor with Arduino. So you can see the ultrasonic sensor over here. So we'll be connecting this to the Arduino. But before that, we need to install some hardware support packages for using this ultrasonic sensor, and for that we'll be navigating to a website which is on MathWorks File Exchange. The link is given in the description box below. So what you guys can do is you can just click on this download button over here and click on toolbox rather than clicking on the download button. And for that you have to you need to have a MathWorks account, which is again for free. So you guys can actually create your account for yourself, and so once you have created your account over here, you can click on the download toolbox button over here, and that should download the toolbox directly. So this is the toolbox. You can save the file, and what I'll do is I'll just open this file location. I'll put it in our directory folder where we are now actually working on. So I'll just go to MATLAB. Okay, I'll have to find it. So I'll put it over here, and I'll simply drag and drop it in the command window in MATLAB. So that will install the toolbox directly, or that will install the library directly, and that's done. The library has been installed. So next what we are going to do is we are going to write a command. We are going to initialize the Arduino Uno. So something is opening, that's why the lab is a bit slow. So this is basically the add-on manager from where you can install the hardware. So if you can also navigate to the add-on manager like I showed you for installation of Arduino packages. In similar fashion, you can also install this package as well. So you have to accept some agreements that installs the toolbox. This might take a few minutes. So yeah, that's done. Now I'll close this thing, and now we'll open that command. So I've connected the Arduino Uno at COM3, and the library which we are fetching is the J Rodrigo Tech library for this ultrasonic sensor. So I'm just hitting on enter. If we and we'll see if the library and everything is installed properly or not. And if that's installed, we are going to go for the connection part. so that we will test the ultrasonic sensor as well. This line of code should work, and let's see. I'm waiting for some results. It again says updating server code on board Uno. This may take a few minutes. I don't know why this is installing it again, since we have already connected it on COM3. The only difference is that I had to remove it before disconnecting the servo motor. So I just unplugged it from the USB and I've plugged the USB again. So this should usually ask, like, the server code usually takes place, installation or updating takes place just once, but this time it's doing it for the second time. And for the same Arduino board, Arduino shows ultrasonic.h for libraries cannot be found. Install the third-party library source first and try again. So there's some error installing this library. Okay, so this error was actually not expected. So what I'll do is I'll simply download the zip folder rather than installing the toolbox. So there might be some issues with the toolbox. So I'm just downloading the zip folder over here. I'll take the same zip folder to our directory and extract it over here. Okay, so these are the actual files which are there in the folder. So this was the error fetched by Arduino, right? No, the ultrasonic slash ultrasonic.h is not cannot be fetched. So let's try figuring out this error. So this is the source folder. I'm just going back again. Now what I'll do is I'll open this HCSR404 example file directly over into the MATLAB, but I'll be opening it through script rather than opening it or running it directly. So this is how you can change the working path, and you can open the script directly. Let's say it says like the hardware setup and all, but before that we need to check if everything is proper or not. So what I'll do is, before proceeding, it might be that we have not actually connected the hardware, so I'll connect the ultrasonic sensor with Arduino, and to do so, can read the guide over here. So there are 4 pins coming out of the ultrasonic sensor, as you can see. One is the VCC, the trigger, echo, and the ground. So what I'll do is I'll put this 4-pin ultrasonic sensor into the breadboard. It fits into the breadboard, and I'll just take 4 jumper wires, which are male to male jumper wires. I'll also require one more extra wire, so I'll be requiring 4 wires. I'm just replacing it with a set of 4 wires. Now next what we'll be doing is the trigger part. Like, the first pin is VCC pin, second pin is the trigger pin. So I'll fit the okay, what I'll do is I'll just move this ultrasonic sensor to the end of the breadboard, and I'll connect the wires behind it. I hope you guys can see it. I'm trying to connect the 4 wires together. This is the last wire. Okay, so I've connected the wires on the breadboard in this fashion over here. Okay, Now what we have to do is we have to connect the VCC pin to VCC of the Arduino. That's the 5 volt of the Arduino. And what I'll do is I'll add few more extension wires so that we can experiment furthermore. I'll tell you later why we are doing it, and that's not in this webinar, which we will be using this ultrasonic sensor, but in the next webinar we'll be creating a project based on this ultrasonic sensor, which is kind of very interesting, and that's why I'm just adding a few more length to the wire so that I need not explain to you again in the next webinar. Now the orange wire over here is the VCC, which turns out to be the yellow wire, and I'm connecting it to the VCC. But before that, I'm unplugging the Arduino so that nothing goes wrong, and if anything goes wrong, the hardware is not damaged. That goes to VCC. Now the last wire over here, black wire, which converts into the violet one, is the ground. So I'll connect this wire to ground. So I've already connected the VCC and ground. Now next, the trigger pin is to be connected on digital 12. So trigger pin over here is the second pin from the left. From this side it's the second pin. So that's red wire over here which goes to the green wire over here. So this is what I'll be connecting to digital pin 13, digital pin 12 on our Arduino board, and the remaining wire I'll be connecting it to pin number 13, which is our echo pin. So these are the connections, and I hope you guys have understood the connection. If you have any queries, you can always refer the connection diagram, which I have already shared on my screen. Okay, so now let us run the code. So for creating the HCSR objects, we'll have to run this part, and I hope this time it would run. I haven't connected the Arduino, so I've plugged in the Arduino quickly. You have to change the COM port. COM port is 3, and run the section again. It says it's busy, and again it's updating the server code on Uno board. Okay, so it's done this time quickly. It says Arduino source ultrasonic slash ultrasonic dot h for libraries. This cannot be found. So what's the error? No, you guys have to figure out this. This is the Arduino add-on actually, and the ultrasonic.h file is not present. So this is the HCSR04 ultrasonic file. Okay, so now you want to find this file. Now the very important thing for this is like you need the Arduino IDE for using the ultrasonic sensor, and that's very important part when you are working with the hardware. So you want to install the Arduino IDE, and for that you can just go to this link over here, download the ultrasonic this zip file from this link, and you have to put that, like you have to extract that file and put it in the documents, the Arduino folder in the library. So for that you need the this is the ultrasonic.h file, and for that you need the Arduino IDE, and now it should work. So I'll run the section now, and it should work very fine now. So again, as I said, I'm trying to take it from the scratch so that you guys don't confuse. I'm showing you each and every step, each and every error, so that it's not just watching the result, watching the end result, but I want you guys to understand how to deal with each and every error. And that's why we create such live coding webinars, when your participation is something which we would like, and we have already told you how you can participate in the webinar by sharing your ideas, by asking as many questions as you can, by commenting down on the video, or getting in touch with us at team@matlabhelper.com. You can get in touch with any of our experts. It's not necessary that it should be related to Arduino only. So it's updating the server code on Arduino Uno board, and this time it's taking time. That means the code should work. So I'm just keeping my fingers crossed, and I'm just waiting for the code to run, and this time it should run. So let's keep our fingers crossed and wait for it. So basically this .h files are the C files which require uh, the which are required for the external hardwares. So in the first part we're just creating an Arduino object, and in the later part we'll be putting the add-on, we'll be using the add-on, and next is something will be actually reading the distance. So this is the main part of creating the object, and many of you guys would you would have failed if you don't know how to install or from where to acquire this ultrasonic.h library. You need not go anywhere. All the links are given in the description box below, so that you guys can easily access them, you guys can easily install them. So I'm just waiting for the code to go ahead. Okay, so now Arduino has been installed with the libraries which are required, and now let's create an ultrasonic sensor object which will trigger pin D12 and which will echo the pin D13. So let's run this section now, and we are assigning the value to variable sensor. So this section is also uh, executed successfully. Now let us run the next section, which is to measure sensed distance in meters. So okay, the current distance is 0.00 meters. Okay, now let me see if anything is in front of it or not. Okay, so we might check. I'll run the code again. This should be in a loop, right? So that it will check the distance. Checking distance again. It says 0.00 meters. Let's check in time if it shows anything different. Measure distance from sensed time. Uh, okay, so that's the difference. I think it's not reading the sensor, like it's not giving it in meters, but when the travel time of the sensor is taken, like this is the formula, so at that time it shows the distance. So again it says 0.82 meters. Now let me run the section. Now it says 0.87 meters. Now let me decrease the section. It says 0.77 meters. Let me decrease it more. It says 0.82. I'm running the section again, and you can see the distance is getting changed. In the next part, like in the next webinar, we are going to do something out of this Arduino, something out of this ultrasonic sensor. So you guys can submit your idea. I'm just blocking it in front of it and running the section, so it should oops, it should decrease the distance. Yeah, you can see the distance is changing. So this is how we would now we have connected the ultrasonic, and we'll be using this same part in our next webinar. I'm telling you again and again because this is a webinar where we are discussing more about the errors, but in the next webinar we'll be discussing more about the projects which we can use using Arduino. So let me demonstrate you one of the project which you guys can easily make. Is something like automated plant watering system, which is very easy. You just need one Arduino and a water pump or a water motor, which you can see in this. Like you can see this is the water motor or water pump, which you can get on any of the hardware store or any of the electronic store near you. You can buy it from there, or you can buy it from us using the Arduino Live kit. It's already provided in the kit. And let me show you the video of this water plant system, and later on I'll explain you about how to program it using Arduino. So here you can see in this video. So this is the video I have taken outside our office in the garden. In this video I've then started the motor into the water, and I've connected it to Arduino on pin number 13, which is the by default onboard LED pin as well. And I've programmed it in such a way that the motor keeps on, it turns on for 10 seconds and it goes off for another 10 seconds. So this is very basic code, you can say, but you can implement it, you can time it as per your requirements, and you can set it like it should run at a particular time. And in the next part I'll be also telling you how to use it, how to control the Arduino, or how to control this motor ultrasonic sensor using your Android mobile phone. Yeah, you heard it right, using your Android mobile phone. So we are also going to develop a few things in the next webinar, but obviously because in this webinar I'm more discussing about you know the errors which you face, which the problems which you face during hardware implementation, and how to solve that problem. Okay, so that's the main purpose of this webinar today. If you guys have any queries, you can just write down below. I'll quickly answer them during and after the seminar as well. So let us see how to code this thing, how to code it in using MATLAB. So the code is very easy, and it's similar to the MATLAB code. Okay, it's similar to the Blink code in MATLAB. Yeah, so you can see this is the code for controlling the motor. Let me show you the connections as well. I'm just removing the ultrasonic sensor connections, and so these are the positive negative wires of this motor. In spite of whatever the positive or negative be, you can uh, put it. Like the black wire, I'll put it in the ground, and the positive wire I'll put it in on pin number 13. Okay, so I've put the positive wire on pin number 13 and negative wire on pin plus. Let me run the code. So this will loop for 10 cycles, wherein 1 second, we need to save this code. So I'll save it on our MATLAB directory over here. So I'm not naming it for now. Run the code. So basically the motor should be on for 10 seconds and it should be off for 10 seconds. I haven't added it, like I haven't inserted it in water, but you guys can do it. You guys can hear the motor has been on for 10 seconds. Now it's off for 10 seconds. Now it's again on. So this is how you can implement this again in the projects. You can use them in your projects. And as I've already told you about the competition, the contest we are going to held, so I hope you guys would be enrolling in it. I'm showing you all the opportunities you can do using MATLAB hardware. So I've already showed the integration of ultrasonic sensor. I've told you how to integrate this a normal water pump. I've told you about the LEDs, and in the next session we are also telling you how to control it using Arduino. But before that, I would like you guys to comment down, you guys to share your ideas, and then we'll be taking it ahead. So that's all for today's webinar.
At the end of this webinar, I would like to thank the Eravat Foundation for supporting us. Eravat Foundation is a technology-based NGO, and if you guys are willing to be a part of this organization or volunteer for the cause, then log on to their website eravat.ngo and contribute your bit. We'll be coming up with more such webinars in the next month, so stay tuned and subscribe to our channel for regular updates. Also, don't forget the Arduino with MATLAB contest and enroll in it today. If you enjoyed the video or have any questions or suggestions, write back to us at team@matlabhelper.com. We would be glad to help you. I take your leave for now and hope to see you guys again in our next webinar. Bye bye for now.